this is our second day of Python basics. So today we want to do Python. We are starting from Python exception handling, like handling of errors. So yeah, we'll do more of like try. What do we do with try, except, else, finally? It's just like basically error handling. Like we are running a code and we just want to code to run, like even if there is error, so we want to give it different options. So I'll just show you how we'll do it. Okay, so let's go to VS Code. So this actually I will do a kind of copy and paste. Okay, so it is the code. So just okay, let me just copy and paste this, and I'll tell you all what it means. So let's just run this. So these actually run. So what this Python basically is um just like, okay, the way you write your normal English. So yeah, we start with try. So what does try do here is try is just for us to, like, okay, if something goes wrong, that the code shouldn't crash, it should continue. So that's why we start with try. You understand? So that if anything goes wrong, if any of how will I put it, any of our like any of our code, if there is error, okay, it should always try another option. So we don't want anything to go wrong in this code. So that's why we start with try. So try x is equal to -1. So so it's an integer. So, and we remember our if statement from our last class. If not is instance. So what this actually means is that this is instance means it should check whether these are variable. -1 is integer. So this is instant. That's what it's doing here. So it should check whether this x is equal to -1 is an integer. So raise type error. If it is not an integer, it should raise type error is just like, okay, it should just raise an error for us. Like, okay, if this assuming if this is 2.0, which is a float. So it will raise this error like only integers are allowed. So, and now this is an integer. So definitely this will actually go through. So for example, let me just give you an instance. Let's say x is equal to 5. So let's try our is instance. So let's say is instance. Okay. Okay, let's say is instance let's say x and int. So this actually returns true or false. You see, true. Can you see? That's what is instance is doing. And we can see this is an integer. Assuming, let's say this is 5.7 to return, sorry, it will return false. Can you see? So we can see that it's true. So definitely the code will go through. So these are okay, followed by if x is greater than 0, is less than 0, sorry, raise value error, no negative numbers. Can you see? And x is 0. You can see x is less than 0. So which is -1. So definitely this will actually go through also. So we raise, assuming if it is 5 now, if x is 5, so definitely to give us this error, no negative number. So this raise is just used to raise errors. So accept type error as TE. So print type error. So this accept type error, this TE means type error. It's just like we can use any number, we can use BA, we can use anything. So accept type error as TE, print type error. So accept value error as VE. VE is still the same thing as value error. It should print this value error. So and accept exception as E, that's normal E. So it should print something else went wrong. So what this is actually saying is if any of these error comes true, it should print these errors for us. You understand? So else means if everything is right, it should print execution successful. Finally, it should print exception handling completed. So that's that. So basically, what we just do here is just for us to it's just to like create different kind of like how we code with even want our code to run through, like we are giving our codes different kind of algorithm, like okay, if this is right, okay, let this code go through. If it's not, it shouldn't, it should raise an error. So that's that. So we can see try test code for error, except undo error, else runs if no error occurs, and finally always runs cleanup, raise manually throws an exception. So that's that. So why use exception error? Prevents program crash. So to prevent our program from crashing. So and handles error gracefully. So it handles error gracefully and ensure cleanup and safe execution. So let's move to Python string formatting. So these literally use F before the string. Okay, insert value using our curly brackets and support. So this is just a way of writing our code also. So let me just give an example. So I will write this. So let's say price is equal to 60. Okay, let's say price is equal to 60. And let's call this variable txt is equal to, so how to write our f string. So we'll start with f in this, and that will be price. Okay, let's say price is I will explain the code actually. I want to make sure the example I'm giving is what is actually here. Sorry. Okay. So price status. If price is done. Sorry. I will explain this. Sorry. Sorry, I think there is an error here. Okay, I think this is where the error is. Yeah, sorry. So Python, most times you have to be careful in writing your code. That'll be price. Okay. I think this should run better. So literally, so let me explain the code. So what this is actually saying is price is equal to 59. So this is txt. This text, we can actually name it anything. It can be anything, just a normal variable. So this is price. So and this is the code here. Price is 2 factorial of 0.2 factorial. Okay. So what this is actually doing is we are putting in a way like this is a way of writing Python in another format using f string. It says that okay, we say price is 59 and status is expensive. So yeah, what the statement is saying is if price is less than 50, it will tell us cheap. So like what I did here is okay, here you can see status is cheap because price is less than okay, if price is greater than 60. Okay, if price is greater than 60, else cheap. So I think this should be less. Yeah, let's do less here. Yeah. Okay, I think my code here, there's an error here. So we actually so so that's what this is actually telling us. It's just a way of writing our codes using F string, literally. I think something is actually wrong with my own code. So in which I need to check. Yeah, this is what I'm doing. Yeah. Okay. Do you see mistake that I actually make? I actually used normal brackets instead of curly brackets. And here I used curly brackets. You understand? That's the error. So we can see price is 60. You can see. And status. Because price is okay, price is great. Okay, let's do this. If price is greater than, let's use greater. Yeah. So that's that. So that is price in two decimal place. That's that 2F. That's 60.00. Can you see? So that's that. So let's go to that's our f string. So let's go to the non-type. So I already told you before, like if you want to find the data type of a variable, we just put type before the variable. Just like okay, let's use this example, the non-type example. So let's say x is equal to none. Okay, we are doing our non-type first. So print type, that's type x. Okay, so you see, so you actually give us non-type. Can you see? It's just like doing x is equal to 17.5. So let's say print type of x. So type is just for you to detect the data type of a variable. So you can say float. So basically, what is none? Represent the absence of a value. Data type is non-type. Only one non-object exists in Python. So basically, so these other example here is basically what we did last week. Our for loop, if we can remember. So you can see. So let me just so I think we can see. So here exam score is equal to 70, 85, none, 92, and none. So none, it has no value. So or it has no score. So rather than leaving it empty, we just put none. So for score in exam score, so if score is none, print score not submitted. Else print score. So if the score is none, you should print score not submitted. So instead of leaving it empty, we put none. So that's the use of a none. So that's a use case there. This is user input. So in these user inputs, we will actually do one or two, like make things interesting, like just like normal like programming. Like I will actually find an example of a use case that we can use that can make it much more practical. So these user inputs basically, what is user input? Allow programs to receive data from user. Python uses the input function. Program pauses until input is entered. So these allow you to input a particular function. So let me give an example. Okay, let me just give a normal example first before doing before actually doing a kind of case study here to make things interesting so you can. So let's make an example here. So let's make a normal example. Let's say name is equal to which name should we use? Okay. Name is input. Let's use our input function. So these are what our input functions works. So that's so just put a kind of comment. Input name. Let's say print. Oh, sorry. So what should we print? So we use our string function to here. So that will be So so yeah, you can see input name. You can see that's what input function does. Like inputs. So let's put a name. Let's put Femi. I think it should. This should bring out. It should bring hello Femi. Sorry. Wow, that's something about Python. There is another mistake in our code. Yeah, nothing new. Oh, sorry.
I think the value should be in curly brackets, right?
There is a little mistake. Thank God, at least we are making the mistakes now. So you can see Python. If there is one single mistake, I should put this name. Like, let's try this. Okay, let's say Femi. Yeah, this should. I don't know why it's not running. Can anybody help us with this? Okay. Yeah, let's try this. I think this is the problem. Yeah. Should this is even an error already? I don't think this will run. Yeah. I don't know the problem here. Yeah, this is fine. Yeah, this should run. Yeah, that's a mistake. Sorry. Uh-oh. What's the problem? Yeah, it should call the name we write. That's what I'm just trying to do here. Yeah, this is the input function. Yeah, that's it. You can see the whole mistake is just you should know when to put the curly bracket and when to know. So reason why this doesn't work with the square bracket is we started with print the square bracket already. So this can actually handle normal square bracket. So Python, no one is above mistakes. So you just have to check well the indentation and how you position your codes and everything. That's very, very important in Python. You can see even me too, I'm making one or two errors. So you just have to check and correct yourself. That's that. So you can see the input function here. You can see we put, let's put, okay, Elijah. So to give us hello, Elijah. That's input function. So let me just walk you through a simple task. So let me try something that I created for the class. Okay. Okay, let's try this first. So this is a question here. So the question should be in Markdown. You can see. So that's Markdown. So build a program that takes a user input grade and categorizes it. If the grade is less than 60, print fail. If it is between 60 and 70, print pass. If it is between 75 and 85, print good. So because of our time here, I think I'll do a little bit of copy and paste. You can always try that on your own too. So this is a solution. I will explain the solution to us. So we can see this. So let me explain the code. Build a program that takes a user input grade and categorize it. So we can see grade is equal to float. So what we mean with this float is a float. Like that means the score will be in float. That's in decimal place. Input, enter your grade when you enter the grade. So now if grade is greater than 0 and grade is less than 60, you can see if the grade is less than 60, you can see it's just like we interpreting our normal English. So it's simple. So if grade is greater than 0 and grade is less than 60, still the same thing as the statements. Print fail. So if it is between 60 and 70, so else if grade is greater or equals to 60 and grade is less or equals to 74, same thing, print pass. You can see. And here, if it is between 75 and 85, print good. So else if grade is greater than 74 and grade is less or equals to 89, print good. So else if again, grade is greater than 89 and grade is less or equals to 100, print excellent. Else, if all these conditions, if the grade doesn't meet any of these conditions, else print invalid grade. So let's try. So these are input function. So yes, it's 75. You can see, good. Can you see? Because 75 is between what? Is greater than 74 and it is less or equals to 89. It is lesser than 89, so it is good. So let's try another input. Let's put 49. That's input function for us. Fail. Can you see that? Any question? So let me just do one more like case study here. Very interesting one. Like our normal ATM, we want to build a program that writes just a program like that runs like our normal ATM. So let me give you, let's make it much more interesting. Okay. So this is a question. So, oh, sorry. Why is it like this? Because it's in code instead of markdown. So that's a question here. So the question says, create a simple ATM transaction simulation program. The program should prompt the user to enter their PIN, and they have 3 attempts to enter the correct PIN. If the correct PIN is entered, the program should display a menu with options, e.g., withdraw, deposit, check, balance. If the PIN is not entered correctly after 3 attempts, print an error message and terminate the program. So this is just like a normal program for our ATM or bank. This program is just for like a bank transactions. So let me put in the code and I will explain the code to us. Just copy it here and paste. So this is the code here. So let me explain the code to us. It's very simple, all what we've been doing. So here, our correct pin is 1234. Balance is 1000. Account balance. We have attempts. We start from 0. The maximum attempt is 3. You understand? So here we are just declaring each variable here. So pin verification. Why attempts max attempts? Why attempts 3 times, which is our maximum attempt? Enter enter PIN. You understand? We should enter our PIN with this input function, giving us option to enter our PIN. So, if entered PIN is correct, so it should print accepted, welcome. So this break is used to break like this, like how will I put it? Is used to break a particular section. Like, okay, after this, we should break and we should start a new, like we should start a new code. Else attempt +1. That means additional. You should try again. Print incorrect pin. Attempts left. You should give us the number of attempts left. Maximum minus attempts. Assuming if our maximum is 3, we attempted once already, so it will remain left with 2. So assuming our attempt is 3, is 2, it will be left with 1. So that's that. So it's just like we just interpreting the English words. You understand? So that's how Python 2 works. So if pin is incorrect after 3 attempts, if attempt is equal to max attempts, print too many incorrect attempts, account logged. So do you understand? It's just normal English. It's just like we interpreted this question. So else, if the attempts are, if it is, if the pin is correct, so that's else. ATM menu, we can see. While true, we should see if it is true. Print ATM menu. It should give us the menu. So we have withdraw, deposit, check, balance, and exit. So choice is equal to input, another input function again. It will give us another, after running, you understand better. It will give another input option of we should choose between 1 to 4. So if 1 is being chosen, it will give us float input amount. That's float of amount. You understand? If amount is okay, if amount is balance, and balance, that will be amount minus balance. So the first one is withdraw. If we want to withdraw, amount is equal to balance. So the amount we want to withdraw, you understand, minus the balance. It's just normal interpretation. Print withdraw was successful, and it should print new balance. Else it should print insufficient funds if what we want to withdraw is more than what we have. You understand? It's just a normal bank operational code. So else if choice is equal to 2, if we are choosing deposit, so it should give us amounts. It should do this for us. Else 3, if you want to check balance, it should print our account balance. So let's run the code. So now it's giving us enter your pin. Our pin is 1, 2, 3, 4. Can you see that? Pin accepted. Welcome. From our code, you can see that from our code. Pin accepted. Welcome, because our pin is correct. So now it tells us to choose option from 1 to 4. From these are option now. These are menu that it gives us. We should withdraw, deposit, or check balance. So let's withdraw. Let's press 1. So enter amount to withdraw. You can see our input function. So we have, you can remember our balance is 1,000. So how much should we withdraw? Let's withdraw 400. You can see withdrawal successful. New balance £600. Can you see that? You can see
Yes.
we use pounds. If we use naira, it will give us naira. If we use dollars, but we use pounds. Can you see that? It gives
Yeah.
us our balance. You can see. So let's check balance. 3. You can see your current balance is £600. Can you see that? and let's exit. You can see thank you for using the ATM. Goodbye. Can you see that? So Python can be used to write to do anything. Okay, basically, Python virtual environment is just like an isolated Python workspace for a project. It's just like creating a workspace for a project. So where you actually store all your packages. Packages like, for example, all the tech stack you are using for a particular program. For example, you are using Pandas, which is for data manipulation. You are using NumPy. We are using all different kind of how will I put all different kind of packages where it will be stored. You understand? Creating a kind of virtual environment like a workstation, like a workspace for that particular project. So, so that's virtual environment. And to create virtual environment, there are different ways depending on your operating system. So, assuming you have like an Apple system now, the way you create a virtual environment on an Apple system is different from the way you create a virtual environment on a Windows. So let me show you example like code of okay. Let me see. Okay, let me just show you how we can create a simple virtual environment. So literally, our virtual environment is being created on our terminal. So all how will I put it? On our VS Code, we have terminal. So this is example of terminal. This is where we run because we can't create a virtual environment on our code. So this is where we run normal functions. Like if you want to pip install some things, rather than running it on your major code, you understand? You run it on the terminal. So let's create a virtual environment here. So actually, this for because I use a MacBook, this is actually for a MacBook. So to run on Windows is different. So let me just okay. I use Python 3, so that will be Python 3. This is just like a constant of how we run the name of my virtual environment. Let's name it Venv. This environment. So that's for MacBook. There's no model named. Okay, let me try Python. I will use Python 3 this time because I don't think I'm using Python 3. Mm. Okay, I think this works. No, 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 no. Just this is just normal constant code. I just want to show you how we create a Python environment. Let me activate. Okay, no source file in the directory. So yeah, that will actually take time because I will need to create a file here. I will need to create a file before I can actually because I will need to create an extra files like a normal project file. You understand? This one is just normal, just our normal class. So that's why it's not actually running. So that's how to just create. It's like a constant. So and we run it on the terminal. That's how to create virtual environments. So just to start up a project, basically. And it's a constant. So, but the code you use for different operating systems. If you are using a MacBook, there's a code you run. If you are using a Windows laptop, there's a code you run. So that's virtual environment. So let's move to okay. So oriented programming. So object oriented programming is a way of designing program using objects that combines data, attribute, and behavior. So why use OOP, object-oriented programming? Organize codes into reusable components, make large program easier. It's just another way of writing your program. You understand? If you want to write this kind of program, you can write it in your own form. So this is just another form of writing program, actually. So now, here, a class is actually declared student. So we created a function. So self and name, self dot name. It's just a way of writing program. So just to write, hello, I am Alex. Before something like this, we write it in F string. You understand? We use F string to write something like this from this. Because of our time, I won't write this one. So we can see from our F string here, from our hello Elijah. You can see just different methods of writing your program, your code. So depending on you, anyone you find comfortable, you understand. So this is just another way of writing our code actually. So file handling. So while file handling is used to store and retrieve data, common in web application script logs and config. Python support create, read, and write, append, and delete. So this basic syntax actually here is okay. Let's move to this. Okay, yeah, these okay. So the normal basic syntax here is R is to read a file. If you want to read a file, R is for reading a file. W is to create or overwrite file. If you want to create a file or you want to overwrite it, you want to add something. So append, add content to the file. X, error if file exists, and text mode T. You understand? So those are the basic syntax here. So this is the code. Assuming you want to like, how will I put it? Okay. So here, file is equal to open, okay, input.txt. So here actually it's just a way to open a file. You understand? If you want to open a file in your code, you understand, you can, okay, this is file is equal to this data stroke input.txt means that's the name of the file. You understand? That's the name of the file, input.txt. So here is just for us to open input.txt. So this code is just for us to open this input.txt. So you can see relative path works on all OS. So this one now is for a Mac OS. So in programming, sometimes in like, oh no, particularly if it's not Python, if like all this if it's just like all this opening of file and almost all this code, basically most times they are being written on in terminals. So there is different ways, like, okay, for example, you want to create a Python environment. There is a way you create a Python environment on a Mac. There is a way you create a Python environment on a Windows or on a Linux. So yeah, to open a file, the way you open a file on a MacBook is different from the way you open a file on a Windows laptop. So that's why I don't want to practice, because I use a MacBook here, and it's my if I write for you now, you might get confused that, oh, this is the way you ran it on in class or something. So yeah, that's why I'm not running. So to write on a Mac is different. And to write on, because the name of this file here is input.txt. It's simple. File is equal to open. That's to open the file and put in. This is just the file directory. This is where the file is in your on your system. You understand? So the difference here is in Windows you put C. In Mac or Linux you don't need to put C. So this basically is just showing us the file directory. So open this file directory. That's the meaning of the whole code. So yeah, another one is read. If you want to read file, if you want to read a file. So yeah, the file is equal to open, the file directory here. You can see this is the file directory here. This example is on Windows. That's why this D or C is there. Assuming if it is a MacBook, you don't need it. So assuming if me I run this code now on my own system, it won't work because it's a Windows. I use a Mac. So you open the file and you print file.read. That means you read the file, what is inside. Have access to the file. That's read. After opening, you read. So read what is inside the file and file.close. You can see it's simple. It's not something too big. So we use with here with open demo file.txt. So that's a file name. So this is an extension. So assuming it's a CSV file now, you write .csv. You understand this is a text file. That is why it is .txt. So that's the file extension. So your file might be stored in any format. So you just have to put the name of the format at the back, dot. So can you see that print file and read? So you read the file. So that's that. So okay. So this one now, A is append. From the last class, I think we did something like append. So and it's just we just use this A, which means append, add content, add more to the file. You understand? You can see demo, that's the name of the file, and just append as file. So that's it. So and file.read, you read it. So W is overwrite. So overwrite on, you replace everything that is on the file before you overwrite. You understand? Like making corrections. So that's W. So these are just simple. W always overwrite the file. A safely adds content. X prevent accidental overwrites. If you want to prevent accidental overwrite, and you don't want maybe other programmers to, because when you are writing, maybe you are writing code for a company, you have what we call Git environment. GitHub is like a repository where you store codes. So that repository, all programmers involved in that particular project can either add or remove from that code. You understand? Because in a very big environment, work environment, in a very big company, you can't be the only data engineer. And moreover, even if you are working on different kind of projects, a data engineer will actually be on the project. A data scientist will be on the project. Maybe a machine learning engineer can also be. Just for example, you understand. So you might have 5 data engineers. So you might be given different stacks. Okay, maybe you just extract all the data we need. So you might extract from APIs, extract from true web scraping. You understand? That's your own section. Like this is what you are asked to do in this project. Just give us the data. You understand? So how will other engineers have access? That is in GitHub repository. So that is where all the repository. So if you extract, you store in the GitHub repository. So every other person will have access to the data. So maybe another programmer now, okay, that you are asked to transform the data. Okay, you do the cleaning, you do everything. Maybe the next engineer, okay. And sometimes you might be the only one. So it depends. So this X is just like, okay, you don't want someone to accidentally overwrite on this particular file you have. So that's it. So that's that. So delete. So delete, we use remove. So this is OS. Okay, we use OS dot remove to delete. So we import this OS. That's like import function. So you want to remove a file now. So you want to remove a file now. You actually use OS dot. OS means operating system. So let me just try one simple. If this will actually, let me try because of. Let me just try this for us. So let's create a file. Oh, I will need a content in the file, and I don't want to use my. Okay, let's say requirements dot txt. Okay, this is a txt file. So let's just do this in my terminal. This is terminal here. So I just want to try this. Let's say I don't think this will actually work on my terminal. Okay, let me try it here. Okay, import. I can import OS to my terminal. I can do this on my terminal too. So let's say import OS. So let's say OS dot remove remove environment dot txt. So let's try that. You can see it's removed. Can you see? So this one is just checking if this file exists, it should remove. You understand? So that's os dot pass dot exit. So that's it. So that's that. So let's move to this basic list and array. We understand our list, the last class from our last class. So these are numbers, these are lists because of the square bracket, and mixed. It's mixed one LO. So a list can be mixed. So that's that. So do you remember our normal like what's it called? Like readings like numbers. Okay. Okay, let me give you example from here. Let's call it class is equal to is a list. So that's 10, 20, let's say 3, 7, 7, let's say 15. Okay. Don't let me use class because of that name. Let's use okay, let's just name it something. Okay, let's name it base. So from here, what's this? Like the numbering, like I forgot the word to use for it, sorry. Like numbering, from the last class, this 10, if you want to read the numbering, like how will I put it? Is it array? Or the indentation? I've forgotten actually what to call. You should understand what I'm saying. Like when you want to start reading, what's this? Normally this is 1, 2, 3, 4, 5. But in Python, things are not read. You can't read the numbers like the numbers of. So let me just. So let's just give. Okay, let's say print. Let's just give an example. Print base let's say base -1. Okay. Print base 0. Okay, that's that. So another thing, remember append. So let's say print, okay, base dot append. We did this last class. I'm just showing you again. Let's append, what should we append? Oh, let's append 17. No, I think, no, this doesn't have print. Base dot append 17. So just want, so another thing we want to learn here is sort. That's base dot sort. So these will actually sort in ascending. So if you want descending, we add descending. So that's print numbers, print base. Okay. So you can see here print -1, 15. Print base 0, 10. Append 17, it added 17. We sort, you can see ascending order. We use this sort to sort in ascending order. You understand? So that's that. So this one now is push. Push is to add elements. Pop is to remove elements. Peep, view top elements. Is empty. Check if stack is empty. And size, numbers of elements. So this is it here. Stack. You can see nothing is inside. So we just declare normal an empty list here. So stack.append, we had A, we had B, and we had C. So print stack, you understand? So that's it. This stack, we print that's we already added A, B, C. You see? Add A, B, C. So this one, pick -1. So pick here is remove. No, you should pick -1. You should pick the -1. The -1 is C. You know, we already had A, B, C. So you pick C. You can see C here. So here, remove is equal to stack.pop. You understand? You remove. That's pop is remove. So you can see print stack after pop, stack after remove. So that's A and B because you remove C. So it's empty. So it's not empty. That's why it is false. You understand? Size, length of stack. You understand? Because we already remove. So the length is 2. So that's that. This is a linear, okay, queue. Okay. So basically, basic queue operations, we have add elements to rear. So that is enqueue. To the rear, to the end, you enqueue. So that's enqueue. Dequeue, remove front elements. That's the queue. From the first element, you dequeue. Pick, view front elements. That's pick. Is empty. Check if queue is empty. Size, number of elements. So that's that. That's not that's a very big issue. Okay, you can see basic queue operations and queue add elements to rear. So queue.append, queue.append A. So basically, this append actually adds A. Queue.append B, you had B. Queue.append C, you know, that's our normal append. So we print Q in Q. So this give us this. So pick. Okay, this one is print pick Q0. So Q0 is what? A, B, C. You start from 0. That's A. So you pick A. You understand? Remove is still the same thing as the Q. Remove is equal to Q dot pop 0. You understand? You remove 0. You remove A. You understand? That's the Q. Print the Q removed. You understand? That's that. So okay, this is what is a linked list? Okay, a linked list is a linear data structure made of nodes. Each node stores data. Reference links to the next node. So nodes are not stored contiguously in memory. Linked list versus array. So these actually, I won't want to confuse you more. Do we really need this for now? No need. Okay. Data structures in Python building data structure provided directly. Okay. You know our list already. It's ordered, mutable, allows duplicates. Tuple, it's ordered and immutable. So that means it cannot be removed. Remember, we all know the set unordered unique elements. It has key and value string. I think we know all this already, so it shouldn't be a problem. Okay, so let's move to okay, what is linear search? A simple search algorithm check elements one by one, works on unsorted data. So this is just an example here. So this is numbers. This is a list. The target variable here is 9. You understand? So we want to know the index of this 9 in this table. You understand? That's the function of this code here. So here we use our for I in range. That means we use range to know from our last class to know the numbers, the length. So for I in range, length of numbers. So the length of all these numbers, if number I is equal to target. So we are saying if this I is equal to target, so we should find this. So you can see they use break here because just to break to make it a whole like okay, this is this particular how will I put it? Will I put use function? No, this part, this is the end of this part. Okay, let's break this. Just this section here. So that's this is the let's say our list is let's say list is one. Let's say our target is it's just old a little. Yeah. So what should we target? Let's target 9. Let's target 5. So let's say, okay, I think that should be right. Okay, that's our for loop. That'll be if, okay. Just say print, just see, okay, found that index, okay. Yeah, I think it should work. I think there is a mistake here. Let me check. Yeah. What's the problem? Something is wrong. Yeah, it's right. Yeah, that happens. Mhm. That's not the problem. Mm. If there is any mistake here, it will actually show where the mistake is. I don't know why it's not showing this. So Normally it should give us the index of this 9. So that should give us. So but I don't know why it's not. So that should be. I will try. I will see the I will see to it. Okay. What is linear search? A simple search algorithm check element one by one. So that's linear search. Okay. And we have binary search. So this binary search is an efficient searching algorithm, works only on sorted data. So if we are working on sorted data, this binary search, because it already gives us index already. So that's the kind of search. This is an example of search because we are looking for the index of this 9 in this linear search. So binary. So let's look at the example of binary. You can see this one is linear. So the binary is like, okay, this number, this target. So we want to find the index of this 9 now. So we do left right is equal to 0. So left right. So that means we're starting from this left 0. Length of numbers. So instead of length of numbers, so instead of 0, 1, 2, 3, 4, so we start with -1. You understand? So y left greater or equals to right is equal to mid. So this is just another method of finding. But I think linear is much more easier than binary. Binary might be actually be confusing for now. So what I will do is it actually ran, but it's not giving us results. So I don't know the problem. So we'll talk more on that. So I already told you sort is just for you to sort. Maybe you sort in ascending order. Yeah. So a merge is for you to merge two things together, like merge two tables together. So that's the example of merge. So so this import pandas. So this is data. So for us to open this data, so so let me just do an example for us. So let me just do example on how to read a data for us. So this is so let me try to add a file. I want to add a file for us. Okay. Let me look for a data. Okay, let me look for a data. Let me just look for a data we can actually work on a little just to see how we open just example of that. Do you have any dummy data here? Let me look for a CSV file. Okay, let me go to my downloads. I think I should find one here. Yeah. Okay, let's use this. This is a CSV file. Yeah. Actually, you have different ways to open your own data, actually. So I just use this. Let me rename this. Okay, this is the name here. I think this should go. Okay, let me use this. So what I just do here is I just put the file, this CSV file. I put it in how will I put it? I put it in into this into our notebook. So I just want to let me see if I can rename this. Okay. So to read the file now, let's say data is equal to read underscore CSV. Okay, sorry. That'll be PD dot read underscore CSV, and I'll just put in the okay, let me copy parts. Okay, copy relative parts, just the parts here. Yeah, just what I just do is copy the parts where this file is. I want to read this file. I'm just showing an example of how to read file. So let me import pandas. So import pandas as PD. This is a constant. So assuming you want to import numpy, this pandas is just for us, like is for us to like how will I put transfer, like in terms it's used for actually for data manipulation to open data and co. So let's try these are data. So yeah, it's run. So let's open data. You can see. You can see it opens. You can see. So it's just that's just an example of how to read a data. Like you want to import a data. So we can see here. So yeah, let's put this into a data frame too for us. So let's use pt.data frame. Okay. Let's put this into a data frame. So to make it much more, df is equal to pd dot. Okay. Hmm. Oh, sorry. Let me do. Oh, to open this, let's say. Let me pick. I'll explain what I'm doing for you. So this actually shows the data. So what I actually do here is just for this shows us the first 10. That's why I put this 10. You understand? So this is the data here. Is the data actually you can see this is the features. This is a column. You can see these are the column age, job, blah blah blah. So it actually opens the data. Is actually the data actually open? This is how it actually shows. It has about 4,500 and something rows. So that's normal. That's the way we open file. You know what I first did is I actually put this data, the file into. I put it into our on our notebook here. And here, what I did here is to read this file. You can see example of read. When you ask like, okay, we should do example of how to read data. So import pandas as PD. So we use this pandas to okay PD dot read underscore CSV because it's a CSV file. Assuming it's a TXT file, it will be read underscore TXT. You understand? So that's that, and it opens the file for us. So that's how we open a file in our in our Python in Python. So that's that. So you can see pandas library. A pandas library is used for data manipulation. You can see an analysis built on NumPy. You understand? Commonly used, so that's it. That's a function of a pandas for us. We can use pandas to read a file. So you can see the outputs here too. You can see it. Oh, these are the columns and these are the rows. So in my data here, these are the columns and this is the rows. So let me just another thing we do to find more informations about the data. So let's say data.info. You can see these are the informations here. So far, I think this should be the end.